It's okay if you don't know the output of this code. By the time this video ends, you'll be able to answer this question confidently and you'll be able to understand why. In this video, I'll be covering 3 major topics. One is going to be callbacks. We're going to talk about promises. And we're going to talk about async awaits. JavaScript is single-threaded. What this means is that it can only run or execute one piece of code at a time, and it has to do it in order. What that means is that if we have a log A, it's going to print log A before it goes on to print log B. Okay, in this our code. What if we have a function here, for instance, called do C, right? And let's say do C, all it does is to log C to the console as well, right? And then we call do C after this second console.log. You see that here we have A, then we have B, then we have C. If we move do C directly before the log for the B, then we have A, and then we have C, and then we have B. That's literally what the single threading in JavaScript means. It means that like it runs one piece of code at a time, and it runs them in order. Now that we understand that, let's assume we have a function after do C, and let's call that function do D, I guess. And all this function does, again, let's keep it simple. Let's just log D to the console, right? But let's assume that this function actually needs to be called after do C is done executing. Maybe it needs something from do C, for instance, right? But like if we call do D directly, right, in that case, if let's say it needs something from do C, the function is going to fail, because at that point it's possible, let's say that this was an asynchronous function, maybe let's say it's a network request or something, it's possible that this function is not done executing, right? So let's assume that this, for do D to run, we need to get like a response from do C, right? So one thing we can do is that we can pass do D as a callback function to do C, right? What that means essentially is that we just pass this function into do C, and let's call this function here. Now you can see that our log updates so that we have A, then C, then D before B. Okay, so callback functions are essentially functions that you pass into other functions to be executed when, or like after the function runs. So a callback is a function, in our case do D, that is passed into another function, in our case do C, where do C controls the time when do D is executed. If you take a look at the logs, you can see that it's still executed synchronously. We have A, then C, D, then B. Callbacks give us a way for our async functions to be able to execute asynchronously. Let us know when it's done before the other one runs. I'm going to simulate a callback, an async function here. Something like, let's say we had like an API request, right? For instance, it should have done something like this. Let's go. All right, now if you see here, what we have now is that this log runs console, this log runs A, then this log runs B, while it fetches this data, or while this our timeout is waiting, right? Let's assume that instead of a timeout here, we have like an API request, right? It runs this code, and then before it comes back, and when it resolves C, once C is resolved, then it runs D. Now this is fine, but what happens when we have an async function that depends on another async function and depends on another async function to be resolved? Let's say we have a do D here. Let's log D for that one, and then let's also have another function, let's call it do E, and let's log E for that one, right? But let's say that they each depend on the other one to be resolved to be able to go to the next step. So let's say we have, let's call that now. We have and then we have do E. Then now what you see is that we have an async function inside async, another async function inside another async function. This is not an issue, but like what you notice is that it's more difficult to understand what's going on here, right? The control flow is just not as straightforward to understand, right? This is what we call callback hell. And also what happens when like there's an error in do D, for instance. Now with this method, what it means is that every single function has to handle its own failure on its own. It becomes difficult to manage. So that's why promises was introduced. Promises was introduced to solve the problem of deeply nested asynchronous callbacks. Just like you can see in this our example, this could go on and on, right? Now, to be able to solve this and make it cleaner, more readable for the user, we had the concept of promises. To be able to demonstrate that, I'm actually going to change these our normal functions to return promise instead. And then set time out, and then instead of a callback here, I'm just going to call the response instead. Okay, so we'll repeat this throughout. So here we have D, and here we have E. Okay, now good. Now what we're going to do here, if you see here, we still have this optional chaining nesting loop going on here, right? That could go on forever. But what we're going to do actually is that we're going to change this response so that you can see what is returned if we use a promise instead. For promises, instead of having this deep nesting, we're just going to have something that goes like do C and do D, so that when D is done running, you do D, then when D is done running, do E. Okay, so now if you take a look at what is printed on our console, you see that first of all we have A logged, right? And then at this point we call do C, but because do C returns a promise, it's like, okay, the status at this point is pending, we'll come back for it later. So it goes on to log B immediately, right? And then once the callback, once the data is resolved, we can actually delete this, right? Once it's resolved, what happens? It then calls C, right? And then the result from C calls D, and then it calls E. And that's why we have it executed that way here. Now, if you compare this code to our original callback code, you can already begin to see the improvements. But then the problem comes that we can actually this can keep going on, obviously, right? But then the good thing is that we can actually catch all the error. For, let's say we have an error in any of these promises, it can get caught at this point, which is great. But then we wanted also to be able to not just like, because if let's say this nesting actually like went on, right, it can actually get messy. Like we can keep chaining this and dot then, right? It can get messy very fast. Now to be able to look at this code and read it better, essentially, right, and not just read it better, we wanted to be able to read it like synchronous code, which is what our brains are kind of used to in the JavaScript world, right? To be able to do that, the concept or the idea of async await was introduced. So that this same function written with async await is going to look something like async function run, for instance, and try await do C await do d, await do e, and we also have a catch. Now, when I'm going to comment this off and then run this, we get back our promise. We have A, then B, obviously, as we explained earlier, and then we have C and D and E, and it reads similarly to the way we would read synchronous code in JavaScript. It's easy to understand. You understand what's going on here at first glance. That was the point of async await. Does that make sense? I hope that makes sense. I feel like this has been like a lot of it has been an info dump, and I hope you're still following. Something you need to remember is that async await did not replace promises. It just made them easier to work with. Now that we understand ourselves, I forgot to mention a few things. Number one, when it comes to promises, we have 3 states. We have the pending states, we have the failed states, and we have the resolved or fulfilled states. Once a promise is fulfilled or rejected, that's failed, it cannot change. That's what makes it so great for callbacks, because there's no way that you have like a callback that is running twice mistakenly. What this can look like in code, you can have P equal to, let's say it's a resolved one, so P dot resolve, let's return 5 when it's resolved, so that you can have P dot then console log. Now let's try this out. Now we have a promise that returns 5. This is a different problem from the one I showed earlier. Now in this problem, we're going to figure out what is going to be logged to the console. First, we have a promise that did resolve to 1. So initially, it's going to return 1. Then the result of this promise, which is 1, is going to be passed into this dot then, and then we have x as 1 now. 1 plus 1 is going to be 2. So it's going to return, the response here is going to be 2. That 2 is then changed to the next asynchronous call, which is going to be this x taking up, that's the result from this one, which is 2. But this time around, it throws an error, which is oops. Now, the moment it throws this error, this promise fails. And once a promise fails, it throws us out of this. And then it returns oops. And then this oops is caught within this catch block. So what's actually going to be printed on the screen is going to be error. Oops. And that's exactly what's printed here. Does that make sense? I think that makes sense. Now let's come back to the initial function that I showed at the beginning of this video. That's this problem here, where we have this promise that resolves to 5. Then the result of this 5 goes in here. 5 plus 1 is 6. And then this 6 is now the new x. And then the promise resolves to 6 plus 1, which is 7. Now it takes 7 here. And then instead of like going on, it throws a new error, oops. And then this oops sets the status of this promise to failed. And then it returns, or it moves on to the catch block. The error moves on to the catch block where the error message is logged as oops. So the result or the output of this code is going to be oops. Do you get it? Do you understand why? I hope that you do. Because if you do, then you finally understand callbacks, you understand promises, and also you understand async await. Before you leave, there are 4 promise methods that I need to let you know about. The first one is promise.all. What this is saying essentially is if you have an array, and this array is an array of promises, right? Let's say that the first one resolved correctly, and one, and then but let's say the second one failed, promise.all is saying I'll wait for all your promises to complete, but if one of the promises reject, I'm going to reject, like the result or the response is going to be a fail, essentially. So let's say we have reject, error, and then p.then, let's console log, and then dot catch. Now, what's going to be printed here is going to be error, just because of the fact that one of the promises failed. If this was, even if we have like a second resolved promise here, as far as one of them failed, it's going to fail. If I remove this, then in that case, it returns an array of all the completed or all the resolved promises, right? But if we don't have, apart from promise.all, we also have promise.all settled. The difference between these two is that promise.all settled gives you an array of all the of all the promises, right, with their status. So you get the status of each promise, you know which one is fulfilled, and the value. Status fulfilled, the value, and then status rejected with the reason. Okay, that's the difference. And then promise.trace, essentially what promise.trace does is that it's like all the promises are on the race against time, right? And then it returns the first one, the first promise that gets resolved. Whether it's if let's say the resolved one came first, it returns that one. If the rejection came first, or if the promise is rejected first, it returns that one. This is important for like cases where you want to do something that fails fast, right? So you implement promise.trace. Right, so let's say that this was a reject. Instead, it fails fast. Okay, that's what I'm saying here. Then the first one is promise.any. Now the difference between promise.all, promise.trace, promise.all settled, and promise.any is that this one resolves with the first fulfilled. So if let's say we have like the reject here first, right, before the resolve, it still returns the resolve because that's the first one, that's the first time the promise was resolved. It ignores all the failures essentially and returns the first one that resolves completely. I hope that makes sense. I'm going to try to stop talking here because I feel like that was too much information. But if you have any more questions, please let me know. I'm open to going more in depth in a particular part of this course. Don't forget to like and subscribe. Thank you very much. Bye.